Okay, so last time we met, I showed you how to use WebSockets on the client side. But if you just try to run that, then you get this error saying that the server doesn't support this. It doesn't even know about the existence of this route. Now in this video, I want to show you how to fix this by implementing WebSockets on the server side. So here is my code for the server class, and you should have a similar one. I am omitting most of it. I just want to show you this part that is doing the routing. So when we have this get game request here that I'm calling game state, when we do this, we are satisfying that part of the API that does the usual get. But we will also want another part that is doing the WebSockets. So right next to this guy, I'm going to say WS for WebSockets. So it's similar like get and put and get, put, and post and so on. But it behaves completely different. Like I told you in the previous video, it is not doing the request response cycle. It is just maintaining this connection open every time. Anyway, now here we are going to create this new action in our controller, and let's call it game state web socket. Right? It's similar to game state, the one I already have, but we are doing that with WebSockets. And currently it doesn't exist, so we are going to create this method get game state WebSocket. So this is my controller. I am omitting most of it, but this is inside my controller class. And I'm going to create this method. So I'm going to call it, oh, and it must be static, like all other methods in the controller, like all other actions. It needs to be a static method. And it doesn't return anything, and it's called game state web socket. All other actions in Javelin, all other methods in the controller, they receive a context. And the context contains the request and the response, or contains the request and lets you assign the response. But because this is a WebSocket, we don't receive a context. Instead, we receive a WS handler, a WebSocket handler, and we are calling that WS. The way you use it is also different. So when reading the context, we would use methods like path_param to get the parameters from the URL, or we would say .json to assign some JSON or to write some JSON to the response body. Well, this time we are not doing any of that. The way we use the WebSocket is similar to the way we used it in the client side, similar to how we do it in JavaScript. So we can say things like onConnect. And onConnect takes a function as an argument, a lambda as an argument, and that function runs when the browser connects. So when we create a socket here in the browser, then we are running the corresponding code in this function that we are about to create. Okay, so what we want to do is to create this function that takes a session as an argument, and Javelin is giving us that argument, this session argument. And what we want to do is, well, two things really. The first is we want to store this connection for later, because later someone will do a move on this game, and we want to send this new game, this modified board, to the client. So we want to store this session somewhere. And I'm going to just create a variable here that I'm going to call, it's going to be private and it's going to be static because I need to access it from this static method. And I'm going to store a bunch of these sessions. So WS session, that is the type of this guy here. And I'm going to store a set of sessions. So one session per each browser that is connected to the server, right? And I'm going to call this the game state sessions. And it's a new hash set. Okay. So the first thing I want to do is to store this session along with all the other ones. And the way I do that is just I say game state sessions, add session. Okay, so that was easy. This lets us know that this session exists later when we have the board change. There's a second thing we want to do here right when we connect. That is, for the first time, we want to give the person that connected, we want to give them the board, the initial board. Because if we do that, then this event triggers, and they see the initial board on the game, on the page for the first time. So we want to initialize this. And the way we do that is we are going to call this method that we are going to create later. So this is some code I wish I had. And I'm going to just use it. So I'm going to say broadcast game state. And what broadcast game state will do is it will send a message to everyone that is connected and that is listening it's interested in exactly this game that we have here. So the same way we could say context dot path param, and we could get the game identifier from the context. Now we don't have a context, but we have a session, and it's similar. So similar to that, we can just grab the game identifier from that session and then broadcast to everyone that has this game identifier and that is listening for this game identifier, right? Okay, so we know that we are interested in having this broadcast function. So let's write this broadcast function. It doesn't need to be public. It really can be private to this controller, really, and it needs to be static because we want to access it from a static method. And it doesn't return anything, but it does take the game identifier as an argument. And now what we want to do is this. We want to, for each session that we have here, so for each game state session, in game state sessions, so for each one of these guys that we have accumulated, there might be multiple people, by the way. There might be multiple people listening to the same game. They're just playing in multiplayer mode. So for each one of these guys, I want to first, let me check if the person is interested in this game identifier, okay? So let's see if the game state session, it has a path param, game identifier, that equals this game identifier, then I will do something because I'm only interested in broadcasting to people that care about this, okay? So I'm checking if the path is, if the session contains the path param that equals the game identifier we are currently updating, right? If that is the case, then I can say game state session send. What send does is it sends a message and it triggers this event handler in our JavaScript, in our client. Okay, so send, what will we send? Well, we want to send the board. And that will be the same output that we generate in the getGame request. So we can generate it in a similar way. Usually people use this when creating a JSON response, but this time we cannot because we don't even have a context here, so it doesn't even make sense. But we do have in the server, we have this getJSON thing that returns an object mapper from Jackson that we can use. And we can say write value as a string that will return whatever we give it as a JSON string. And what will we give it? Well, we want to get the repository, and that is how I modeled my lights out game. You might have done something different, I don't know. But in any case, I am getting the game from the game's repository. I am getting this game. And this method might throw a bunch of exceptions, so I'm just going to say that now my method can throw a bunch of exceptions as well. Things like not being able to access the database and so on. So that's it for the broadcast function, really. Now we get this game identifier and we broadcast to everyone that is interested in this game identifier. We are broadcasting this is the new state of the board. This is how we do it. And now coming back to the game state WebSocket, okay, so we remember all the sessions, we broadcast the initial game to the sessions. There is also something else we need to do. Consider what happens when you close the connection, and we are closing the connection right here. Okay, so consider what happens when we close the connection. Well, the server keeps track of all the sessions that are alive. So if we close the connection, we want to forget that. So what we can say is that WebSocket on close. Now this is a function that will run when we close the connection here from the browser. What we want is, well, this is also another function, another lambda will be called. And this time it takes 3 different parameters. The first is the session. So that's what we already know from here. It's the same one. But it also takes a status close and a reason. And these are 2 things you can tell when you're closing the connection. You could say, I am closing the connection with a status code. The status code, it can be similar to one of those HTTP codes, for instance. And you can tell a reason. So you can say like, I am done playing this game. And whatever you say here will end up as this argument here, reason, right? So that's it. And you can do stuff with the status close and the reason, but for this simple example, I'm not going to. I don't need. So all I have to say is that the game sessions, from all the game state sessions, I want to remove this section that was closed, right? And this is so simple that I can replace it with a lambda expression. So it is easier on the eyes. Now we are dealing with the sessions appropriately. We are remembering them and we are also removing them. Before we go to the browser and try to run this code, there are 2 things we need to do. And I did this off camera. I need to add the call to broadcast game state in 2 different places. Those are the 2 different things we need to do. We need to add the call to the broadcast game state to the end of the move method and to the end of the cheat method. So in general, anything that might change the game state, that might change the board, I need to add a call to the broadcast game state so that all the clients that are interested in this game are notified. And I already did this and refreshed the server. So I am now running the server with this code as well as those changes that I did off camera. And I'm ready to come to the browser and refresh. And now I'm seeing the game. I can play the game. I can cheat. It works the same as before. But notice that we are not doing one request every 200 milliseconds. We just have one WebSocket open to the server. Sometimes we get this data when something changes, like this other type of request here. It's not really a request, it's a network interaction of the other kind because it's coming through a WebSocket. So that's all there is to WebSockets. And in the next video, we are going to change subjects. We are going to re-implement most of these things in the server in a client in a more structured way. Because currently it's 35 lines of code and we can reason about that because it's short and sweet and it fits on one screen. But it's not a good pattern for growth. I mean, we are just defining a bunch of functions at the top level. And if we had a big app, this would not scale well. So in the next video, we are going to start learning about the class system and reorganize this code. And we are also going to learn one thing or two about refactoring, because we will be refactoring this code to do exactly the same it does now in a more structured manner, improving the architecture. I see you there.